Well, in this case, we are going to explain the solution of logarithmic equations. And to explain the solution of logarithmic equations, I have these three examples. In the first case, we have a logarithmic expression equal a number. When we have, when we have a problem like this one, you know, there is a logarithmic equation, a logarithmic expression, equal a number. Then what we have to do is to apply, you know, the conversion of logarithm to exponential. Then you know that if we have logarithm in base 3 of 2x minus 1 equals 2, you know, or just in general, write logarithm in base b of x equals y, we can convert this into exponential, like b to the y equals to x equals to the argument of the logarithm. Then using this same rule, we can rewrite this like 3 to the second equals 2x minus 1. 3 to the second would be 9 equals 2x minus 1. Then we bring the 1 to the left, adding 9 plus 1 equals 2x, right? Equals 2x. Let me erase this here. Then 9 plus 1 is going to be 10 equals 2x, and 10 over 2 equals x. Then x would be 5. The solution of this equation is 5. Always, when you solve a logarithmic equation, you have to check that the argument is greater than 0. Then you have to get a 5 that you got a solution, and you're going to plug it in here. 2 times 5 is 10, minus 1 is 9, is correct, because 9 is greater than 0. Then no problem, my solution in this case is 5. Now I have another different logarithmic equation here. In this logarithmic equation, we have an equality between two logarithmic expressions. When we have an equality between two logarithmic expressions and both logarithmic expressions have the same basis, right, we can make the arguments of the logarithms equal. That means, in this case, to solve the equation, we do 3x plus 2 equals x minus 6. 3x plus 2 equals x minus 6. Now we solve the linear equation, you know, then 3x minus x equals negative 6 minus 2. We bring the x subtracting to the left, we bring the 2 subtracting to the right. 3x minus x is going to be 2x equals negative 8, right? And then we have x equals negative 8 over 2, x is equals negative 4. And in this case, the solution is negative 4, right? Then now we're going to check, right, that this negative 4 keep my arguments as positive values, right? Then when I get the negative 4 and I plug in the negative 4 here, or I plug in the negative 4 here, 3 times negative 4 is negative 12, plus 2 is negative 10. That means this will be negative. Negative 4 minus 6 is going to be negative 10. This argument will be negative. Then negative 4 cannot be solution because the argument becomes in negative. Then what is the solution set in this case? In this case is no solution, or your solution set is the empty set, right? Because every time that your solution make your argument 0 or negative, you have to reject that solution. And finally, we have in this case, this logarithmic equation that involve more than one logarithmic expression in this left side, then what are we going to do is just to, using the properties of logarithms, combine these two logarithmic expressions. We know that when we have a subtraction of logarithmic expression, we have to rewrite that like a quotient. Then this will be equivalent to the logarithm in base 2, of x plus 1 over x plus 3, using the quotient property, equals 2. Now we have a case like the first case I explained, where a single logarithmic expression is equal to a number. Then we do 2 to the second equals the argument x plus 1 over x plus 3. Then 2 to the second is 4 equals x plus 1 over x plus 3. We bring the x plus 3 multiplying to the left. We get 4 times x plus 3 equals x plus 1, right? And then when we multiply, 4 times x is going to be 4x, 4 times 3 is going to be 12, and here we have x plus 1. And now we're going to group the x together. We have 4x minus x equals, then we bring the 12 subtracting, negative 12 plus 1, or 1 minus 12. 4x minus x is going to be 3x. Negative 12 plus 1 will be negative 11. X is equal to negative 11 over 3. This is, in this case, my solution. Now we'll check if this solution, right, give me positive arguments or negative arguments. Then when you substitute here the x, right, if you substitute this x here in your original equation by negative 11 over 3, what happened? Negative 11 over 3 is negative 3.67, right? Is bigger than 1, then this will be logarithm in base 2 of negative 2.67, right? And the question is that we have the logarithm of a negative number, and for that reason we must reject the solution. And in this case, again, we have no solution, or the solution is the empty set, or set with no elements, right? And always you have to remember that at the end you will check if the number that you get as solution is really solution of the equation or not. Just plugging in this number into your argument to make sure there is greater than 0.